Is everybody locked in yet? Okay. I want to make sure everybody's head's on the same page and that we're all doing what we should do here. First off, this is a substitution question. There are still a couple of you who are trying to use the elimination technique. You only use the elimination technique when they line up. The x's don't line up here, the y's don't line up, the equals don't line up. So you're not going to use elimination where you multiply both of them by different numbers and stuff. You're going to use substitution. And if you notice, I rewrote the top equation. The 4x minus 2 stay the same, the equals 14 stays the same. But I trade in the y. I trade in a y because the y is equal to an x minus 3. So I put the x minus 3 in place of the y, and now I just solved the equation that was there. By far, Matt, I'm getting frustrated. You turned around again. Just pay no attention to him. If he's talking to you, which I definitely believe could be happening, just ignore him, right? Because I think that the level of success you're used to and some of the people around you is not the same. And the more you pay attention to them, the more your success is going to go down. And I don't think you want that. Now, here's the big mistake that I saw a lot of people make. God bless. Mike Cardenas, I think you made this mistake, so pay attention here. Ready? What kind of 2 is this, everybody?
Negative.
Negative. So the 4x stays the same. Then negative 2 times x is negative 2x. And you all had that on your papers, but many of you put minus 6. What is negative 2 times negative 3? Positive 6. Regular 6. That was the big mistake. And some people came out with x equals 10. But x doesn't equal 10 because this should be positive 6. Then you subtract 6 from both sides. Then you divide by 2 and you get x equals 4, not 10. Then I go back, I can use either equation, they both work, but I'm going to go with the bottom one, y equals x minus 3. Plug in the 4 for x, y equals 4 minus 3, y is equal to 1. Okay? Any questions about how to solve for x and y? Alex, head in the game. Then there's the check. To do the check, and today's check was better than any other day's check, but we're still not 100% there. I put the boxes around those 2 lines because those are the 2 original equations. And I rewrite them, I put them over there, and I leave space in between to do a little bit of calculation work. Every place I see an x, I put a 4. Every place I see a y, I put a 2. And then I just do what it says. 4 times 4 is 16, 2 times 1 is 2, 16 minus 2 is 14. Yeah, 14 equals 14. Here, the y is 1, so I put a 1 in, and the x is 4. 4 minus 3 is 1, 1 is 1, yes, check, and I end up with the correct solution. Okay? Are there any questions about this one?
No.
Okay, very good. Now let's talk about today's lesson sheet. Is this the same sheet you guys have?
Yeah.
Right, questions match up?
Yeah.
Good, very good. Now, let's go through this step by step, and hopefully we're getting really good at understanding what it is we're saying with functions. And that's really been the point behind the first 3 days of this particular unit, is to understand function terminology, what we're talking about when we do functions. I like to say this. I am a smart man, I really am. And it might sound like bragging, but I am a very smart guy. I excel at history. I can write really, really well. I do math for a living. I have a degree in physics, which is the hardest of the sciences. I study philosophy. I study theology. I study dog pedigrees. I'm into dogs. I'm into entomology.
What's that?
Entomology is the study of bugs. And the reason I'm into it is because the fish that I try to catch eat the bugs. And the more I understand about the bugs, the more I know, or the easier it is for me to catch the fish. I am into tides and currents because I fish in the salt and I need to know where the bait's going to be. I just like to learn. I'm into politics. I love the history of our country. I love to learn. Learning is a really important thing to me. But if you took me, as smart as I am, as learned as I am, as much as I like to read for the sake of reading, I'm reading a veterinary book right now on dogs becoming pregnant and whelping the litter and keeping them healthy and so on and so forth. I have another book I'm waiting to read called Washington's Immortals, all about how this one particular group of soldiers under George Washington saved the Revolutionary War. I just finished a book about how a group of soldiers fought in World War II and captured Pointe du Hoc, well, Pointe du Hoc, I kept saying Du Hoc, but it's Pointe du Hoc, in France, and if we didn't do that, we couldn't have won the Normandy invasion, and then, who knows, we might be speaking German. I'm into all of this kind of stuff, and I learn it all. I'm smart, I'm intelligent. If you took me and you dumped me in the middle of China, put me on a plane, dropped me out of a parachute, had me land in the middle of China, I would be so lost. Despite the fact that I'm smart, despite the fact that I like to learn, despite the fact that I've been successful all of my life, if I don't understand the language, I can't possibly be successful. I have these two friends, Katerina and Victoria. They mean so much to me on so many different levels. Not only are they good friends, but on top of that, I love this dog breed, these Central Asian Shepherds, and the peoples who have done the most work with Central Asian Shepherds are the Russians. Do you think I know Russian? Not a chance.
Yes.
But Katerina knows Russian, and she'll get on these websites and read it in Russian and translate it and send it to me so that I can begin to understand it. Now, once it's translated into terms that I understand, I can use that brain power I have, and I can come up with some good ideas. But until Victoria and Katerina say to me what it is that I can't understand, my brain is useless, completely useless. So, that's how your brain is. See, we're about to do all this stuff with function theory. We've been working on it a couple days. And if you don't understand the language of functions, it doesn't matter how smart you are. You could be a super genius. You could be someone who's got 90s in math all year long, an A student, and you're not going to do well. The girl Victoria, who I'm friends with, I help her a little bit with her history because she was born and raised in Lithuania. She spent her whole life growing up in Lithuania. She's got all these papers about American history. That's great, but if you weren't born in America, how are you going to know about American history? She was born in Lithuania. Now, you ask me about Lithuanian history. Do you think I know anything?
No.
Not a chance. One day, she and I got into this discussion, and she sent me this. Text message, and she just wrote something like January 13th, 1990. Oh, January 13th, she wrote, and I wrote back question mark. I don't know what you're talking about. Then she wrote 1991. Okay, it's a puzzle. Again, I don't know what you're talking about. So, you know, not being stupid, I went into to Google and I typed January 13th, 1991. And up came something I knew nothing about. A horrible, horrible event where the Lithuanian people protested for their independence. And the Russians came in and put down the protest violently and killed people and beat up and injured over 200 innocent Lithuanian citizens. And she told me, she said, she walked through puddles of blood to get home that day. Now, she is rabidly anti-Trump, hates him. And the reason is because she sees in Trump some of the qualities that she has seen in Russian leaders. And she has seen the bad side of what Russian leaders have done. And she's afraid that that bad side might happen here in America too. So again, do you think I understood any of that? No, of course not. I didn't understand any of it because I'm from Lithuania. If you don't understand this language of functions, you're done. You will not get anything right in this chapter. On the other hand, if you do understand the language of functions, that brain power that you have, that intelligence that you have comes out. Once I understood what happened on January 13th, 1991, everything changed for me. I began to see where she was coming from. But before that, I was like, I literally said to her, why are you getting so upset? What are you thinking? And that's when she sent me those texts. Okay, so here we go. A little bit of review here about volume, or more specifically about operating with these numbers. Volume of one cube is 8 times 10 to the 8th. The volume of the second is 2 times 10 to the 6th. How many times bigger is the first than the second? And we said yesterday, when we get these big ugly scientific notation numbers, before we ever attempt to do it in scientific notation, which can get confusing, instead, we try to do it with regular numbers. So just call the first one 8 and the second one 2. How many times bigger is the first one than the second one? 4. And then to do that, I do 8 divided by 2. So now I'm going to take the whole expression, 8 times 10 to the 8, over 2 times 10 to the 6th. What's 8 divided by 2? 4. 10 to the 8th over 10 to the 6th is? 10 to the 2nd. And which choice equals 4 times 10 to the 2nd? C, 400. Very good. All right, which of the following could be the graph of? And this is 1/3. Look like this?
Yeah,
All right.
wait. Oh, it's negative, remember.
Now, which of the graphs could be the graph of x equals 2? X equals 2 goes just like that.
Yeah, we don't have something like
Yeah, I
that.
can put
That's
that
why-
there. All right, so that's what it should look like anyway. Next, what's the solution here? One thing that this particular question teaches you, we have a habit so often in equations where we kind of work always getting the variable on the left. And the idea is to keep the variable positive. So the best step here is to add 5x to both sides. And I get 4 equals 7x plus 18. Then I'm going to subtract 18 from both sides. I notice it's having a hard time fitting here. When I subtract 18, I get negative 14 equals 7x. Divide by 7, x is negative 2.
Oh, I got that.
Nice, yes.
Let's say you tried to get a variable on the right, but you still get the same answer.
Yeah, you would get, your previous step would be negative 7x equals positive 14. And then when you divide by the negative 7, you'll also come out with negative 2.
Yeah, that's it.
It will work the same either way. And can I tell you something, Josh? That's one of the things I really find comforting about math. I really do. I would strongly suggest, for all of your sake, that you never get in an argument with me, because you're toast.
Oh.
Yes.
Am I?
Yeah, you're done. The reason is not that you're not smarter than me. You could be smarter than me, hands down. The problem is that my brain has been trained through all of these courses I took in college to think about proving something. And to prove things, you have to have ironclad, no wiggle room left over. That's why when you take my brain, and not because I'm some super genius, please, it sounds like that, I don't mean it to, I apologize. My mathematically trained brain, that's trained to look for logical flaws, and you apply it to something like history. And if I write a paper on history, it's really convincing, because I don't leave out gaps in what I'm proposing or what I'm saying, because of the math training that's within me. And the reason is because in mathematics, you arrive at an answer, and it doesn't matter which way you come to that answer. That's the answer, I can prove it, that's the end of that. We take classes like social studies. I'm a conservative guy. I believe in conservative principles. If I was teaching history and you wrote me a paper all about progressivism and how liberal papers or liberals have the ideas right, my immediate reaction is you're wrong. That you don't have a clue. Progressivism never works. But you know what? I can't absolutely prove that. And if you're a conservative kid, and both of my sons are conservative, and they had this one teacher who was a feminist at the high school by the name of Mrs. Seaborn, and they used to write papers for her, and the papers were beautifully written, and they were sound and argued well, and she would not give them good grades because she disagreed with them, even though their work was excellent. In math, that can't happen. If you get x equals negative 7, I don't care if you move the x to the left, I don't care if you move the x to the right, x is negative 7. That's the end of the issue. So I find that comforting. So if I have a teacher that doesn't like me, I still get credit for the answer. So that is something I think is pretty cool about math. Now, of course, the social studies teachers will totally object to what I just said. Okay, in the function, what's the output if the input is -4? Input means I put it in for x. What's -2 times -4, everybody? 8. And what's 8 minus 5? 3. So choice A is the correct answer. Now, every graph that we have done up until now has always looked like a straight line. And we call any graph that looks like a straight line linear. Think of what we just drew a minute ago. First off, this we said is y equals x squared. We just drew this graph a minute ago that looked like that. Remember it? All right. That's what we call a linear graph. Right. And linear, what are the first four letters of linear?
Fine.
Line. So a linear graph is a graph that looks like a straight line. We've been doing lines for the longest time. Y equals mx plus b, y-intercepts, x-intercepts. We've been doing all these different ways of graphing lines. Well, today, for the first time, we graph something that doesn't look like a line. We're going to graph this function y equals x squared. And we're still going to use Sticky the Stick Man, our buddy who lives in the calculator. We're going to give him an input. He's going to reach up, grab the input, do what he's told, and then give us an output. So for this one, in my table, I'll have x, y, and I'm going to input -2, 1, 0, 1, and 2.
Why?
Because you're going to see what happens. What I want to do is show you the graph, and I want to show you a graph that's not a straight line, okay? So again, we have input and we have output. Does anybody remember? I only said it once yesterday, so if you don't remember, this is on me, not on you. What's the word for when you put all the inputs together, a set of all the inputs? It starts with a D. With a D. Domain.
Oh, yeah.
Okay, I'll put it up on the board in a minute. Do you remember what all the outputs is called? It starts with an R. Range. Someone over here said it. Yeah, range is right.
Thank
All right, I'll remind you of that in just a minute, and we need to get pretty comfortable with that. What I just wrote in the X column of this table is the domain. -2, -1, 0, 1, 2. Those are all your inputs. Now, all I have to do is follow the rule. The rule is to square them, which means to multiply by itself. So what is -2 squared? What's -2 times -2, guys?
Positive.
+4, good. Now let's do -1 squared. What's -1 times -1? 1, good. What's 0 squared? 0. What's 1 squared? 1. What's 2 squared? 2 squared? 4. Someone said 2, I think there. A little bit of a mistake there. Now, if I wanted to do it as a picture, it would look like this: -2, -1, 0, 1, 2. And then over here, we'll go 4, 1, 0, and then the same numbers again. So it's a little bit of a messy picture, but it is still a function. Remember how the other day we said if one of these guys in the domain, remember I said I would write it on the board for you?
Yeah, I wrote it.
And if one of the guys in the domain has 2 different lines going from it, it's not a function. But if it has 1 line going from it, it is a function. It doesn't matter that it goes to the same thing, that's fine. Josh?
When you put the -2 in, aren't you supposed to keep the negative because only there's a
No. There's a big difference between these two things. And if you remember, Josh, early in the year, this was on like your first 5 tests in a row. -2 squared means square only the 2, then negate it. This is -4. This means square the whole -2, which is -2 times -2. And that was 4.
Exactly.
And that's why we made it a point. It was like #1 on every single test, to drill into everybody's head the difference between those two things. Okay, so this is a function. That is a picture of it as a table. Now, to write it as a set of ordered pairs looks like this: -2, 4. Oops, sorry.
There's already a picture on it.
Is there?
Yeah.
-1, 1, 0, 0, 1, 1, 2, 4. All right, so there it is as a set of ordered pairs. Now, all of those are ways to represent functions. We have ordered pairs, we have a picture, we have a table. There's one more way to do it. And that cool thing to do is graphing. And when I graph this guy, it's going to look like this. I'm actually going to go out to -3 this time, just to help it out. 2, 4, 8, 9. It does look like a U, okay? First off, in any way, shape, or form, does that thing look like a line? No. So it is not linear. Let's be perfectly clear about that. This has its own name. This is called a parabola.
A problem?
Parabola.
Long word.
Medium. I wouldn't call it long.
That's a.
Supercalifragilisticexpialidocious is long.
Oh, I get that.
Can you spell that?
I've actually tried. I think I could do it if I had to.
I know how to.
All right, parabola. That's what that shape is called. And here's the thing. You always get a parabola when the highest exponent is squared. Anytime you see the highest exponent squared, your shape is always going to be a parabola. This is called, another name for this is quadratic. Quadratic. It is not linear. Okay? David, you had your hand up.
So, what would happen if it's under one?
If-
Like if it's under two, what if it was one?
What you mean it? You mean the exponent?
Yeah.
Then it's linear.
Oh,
See, we've done linear, like, this is something we've graphed a lot. Y equals 2x plus 4. We begin at 2, begin at 4, I'm sorry, up 2 over 1, up 2 over 1. There's my graph. The exponent is 1. I don't bother writing it, but that's what's there. And my shape is a line. All right? Very good question. All right. A linear or a line has a constant rate of change. That constant rate of change is called slope. There's a variable rate of change in a parabola. See, the slope is like that there, but over here it's a little different. Over here it's a little different yet. Each one of these slopes is a little bit different. There, 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 there. So a parabola does not have a constant slope. Its slope changes at every single point along the path of the parabola. Okay? All right, let's take a look at the next one. All right, this time y equals x squared minus 5. Is there a picture on your paper?
Yes.
I don't think so. I think the table's there.
that's fine.
All right. So what values are in the table here? X, y, and then the x is what?
Negative one.
Okay, so -2, +2.
Negative 2, negative 1.
And then the rule is y equals x squared minus 5. So what's -2 squared? We did that before. 4 minus 5 makes -1. That's how I made the table. What's -1 squared? Guys, -1 squared. Come on. 1 minus 5 is -4. 0 minus 5 is -5. And then it just repeats again. -4 to -1. And then, let's write that, folks, let's write it as a set of ordered pairs. That's the last thing we're going to do today. Hey, you should not be packing up. You should be writing it as a set of ordered pairs. Okay, there's my set of ordered pairs listed across the board. Okay? Any questions? No. All right. We will keep exploring functions every single day until we get to our test next week. I was thinking about that before.
Kristen has,
I don't know. Maybe it's a lead. Maybe it's like co-leads. I don't know.
it's usually like,
Can I ask Kristen who? Kristen Rafferty. Okay.
it's usually if you're at the top of the list, you're the lead.
Right.
So Nick is, the guy, and I guess I'm the female.
You know what? That would be a question more for Mrs. DJ.
That's what Lee's mom said that too, because,
You know, for all you know, she was looking at the playbill and looked at whose name came up first. You know, could it be because they have the first part in the play? Who knows?